So example 1 for simplifying rational expressions, multiplying and dividing rational expressions. In this case, we are going to be looking at 3y times y plus 7 all over y plus 7 times y squared minus 3. Or sorry, y squared minus 9. So if we want to simplify this, you know when you have, say it's 14 over 21, that's the same thing as 2 times 7 over 3 times 7. You can reduce the 7s because 7 over 7 is 1, and you end up with 2 over 3. So if you've got the same thing top and bottom being multiplied, they basically become a 1, and you can simplify them on out of there. Sorry, my eraser has trouble catching up with me sometimes. So in this case, we're going to look at the top and the bottom, and we're going to simplify what has the same. So we've got a y plus 7 and a y plus 7. So I end up with 3y over y squared minus 9. And then I'd have to look at what the y squared minus 9 actually is. And if you remember your factoring here, this is a difference of two squares. So this is a y minus 3, y plus 3. And then you can look at the top, at the numerator, and you see there's no numerator that's the same as something in our denominator. So we are, in fact, simplified. And this would be your simplified answer. But we're not quite done because we have some issues that could go on here where you can't have certain values. And what do I mean by this? Well, are you allowed to divide by 0? The answer to that would be no. So we have some cases where this could actually have a 0 in the bottom. So if y plus 7 was equal to 0, that would mean y would be equal to negative 7. So in the case where y is equal to negative 7, you would end up with a 0 in the denominator, because any 0 times anything is 0. So we can't have that. Y is not allowed to be a negative 7, just for the fact that you would then be dividing by 0, and our whole function here would be undefined. Likewise, if we look at the other side of this, you've got a y minus 3. So y minus 3, if it were 0, it would mess up the whole thing and put a 0 in our denominator. So y can't be equal to a positive 3. And the last one over there, if y plus 3 were equal to 0, then y would be equal to a negative 3, and that would also make our entire denominator negative. So in this case, we can't have y equal negative 7, y equals 3, or y equals negative 3, because it would make our function undefined. There is no answer to this in those three cases.